Okay, so for homework number 6, Tracy Gardner's heat and mass class, for the first question we were asked to find the heat transfer coefficient for a plane flying at some altitude with some surrounding specifications. And first thing we did was go to handout number 5, get the properties for the air that the plane was flying through, and then we applied the ideal gas law to get a density for the given pressure that we're at. Once we found the density, we could then use the Reynolds analogy, which puts together the relationship between the Nusselt number, Reynolds number, and this PR to get your H value, which is found in your Nusselt number. Since we were given all of these values and solve for rho, we can then solve for the H for this question. The next question is 7-28, which had this external flow through finned surface, which also had some base to it, and we were asked to find the heat transfer again, as well as the feed velocity stream value. To get this, we used properties again. Instead of the temperature given, we used the T average, since there's an average temperature between the surroundings and the fin surface area. We get this value, we get the properties, and then we find the areas of the fins so that we can find heat transfer for the fins, which is then solved for with the Nusselt number to get H, or to get the Nusselt number. Once we found the Nusselt number, we know that it's laminar, so we can use the laminar form of the Reynolds number to get the Reynolds number. And then we can use this equation, which has the free stream velocity in it, and we can solve for the free stream velocity with the Reynolds number and the dynamic viscosity. For this question, we had an internal flow type problem with water traveling through a pipe with an inlet and outlet temperature, and then there was also some absorption from the sun. Given, we then found the T average again and the properties for that T average, and then we also needed to find the total heat transfer for the system. So we used m dot Cp the times the change in temperatures. Once we had that, we can then use that in relation with our given heat to find the wanted length for the section of the pipe. Then we were asked to solve for the surface temperature of the pipe, and to do this we needed to find the Q as well as the heat capacity. So we solved for the Q, the H, the heat transfer coefficient, by using the Nusselt number as well as the Reynolds number and a hydraulic diameter. Once we found that, we knew that we were working with turbulent flow, so we could use the Nusselt number equaling the turbulent equation, solve for a Nusselt number, and get an H value. Using that H value, you can use a little q equaling h times delta t to solve for the H value. This next question had a box that was being cooled by a fan. We were given the dimensions, and we were asked to solve for the friction, or the fraction of heat lost in the system. To do this, we needed the sum of the Q's in the system over the total amount of Q's consumed, and the sum of the Q's was equal to the heat coming out of the top, the heat coming out of the sides, and then the heat coming out from radiation. To solve for the top, we used a RA value. We solved in conjunction with the Nusselt number to get an H value. Once we had our H, we could use the area at the top plus our H at the top to get the Q at the top. The same process was then repeated for the side, and then the radiation heat was solved for with the radiation equation. All of those were summed up and divided by the total to get a fraction of heat loss, which was 16%. lastly, we had this question right here, which asked for laminar flow through this surface. We followed the similar processes, but we needed a heat capacity or a heat coefficient that was altered to fit the specifications in the problem. So we used this equation right here to get that, and then using that we could solve for the variation in the heat temperature given a change in x for distance. We could then use that to solve for the heat transfer coefficient for both different types or different lengths given x. And yeah, thank you.